Hello everyone. In the last video, we have already discussed about logistic regression code. So while discussing that, at last we have seen one technique in order to measure how good the model is. So that technique is accuracy, or that particular metric is accuracy. So in accuracy, what is the formula? The formula is, so in the denominator we'll be having number of data points, and in numerator, out of all of these data points, how many are correctly predicted? So this is our accuracy formula. If we see it something theoretically, so accuracy will look something like this. Right? But do you guys think, is there any problem with this particular accuracy? So if you carefully observe, there is one slight problem with this. Let's say my model is looking like this. Let's say I'm trying to build some binary classification model using, let's say, logistic regression. And for such binary classification model, like there will be two classes, right? Let's suppose those two classes be 0 and 1. And the number of points that we are having in our data set with 0 are 800, and number of points with 1 are 200, let's suppose. So like this, my data distribution is there. And for such data, let's say model is predicting everything to be 0. What does that mean? Then what will be my accuracy corresponding? So according to this, what will be the total number of data points? It will be 800 plus 200, that is 1000. And among this 1000, as everything it is predicting to be 0, how many will be correct? So for all the zeros, it will be giving correct result. For the one actual outputs one, it will be giving wrong output. So in this 1000 total, it is telling, or it is correctly predicting for 800 points. So what will be my accuracy in that case? My accuracy will be 80%. If we see this particular accuracy, we might feel that my model is giving 80% accuracy. But actually, is it giving 80% accuracy? What do you guys say? Basically, there are two kinds of data sets. One is balanced and the other type is unbalanced. Let's say I'm having 1000 points. So whenever we are having 500 and 500, then we can say balanced, or 550 and 450. Then also to some extent we can say it is balanced, and also 600 and 400. Then also we can say to some extent it is balanced only. But if it is very unequal, like 700, 300, okay, or 800, 200, or 900, 100. In such cases, we say that our data set is unbalanced. So whenever we are dealing with such unbalanced data sets, accuracy is not a good metric. Okay. So if you are going on with, or if you are having some kind of unbalanced data, it is better to go for some other metrics apart from accuracy. So those metrics are called as precision, and then recall, and finally we are having something called as F1 score. These are the other metrics apart from accuracy through which we can find how good our classification model is. Okay. Let's try to understand each of those. Before going on to these precision, recall, and F1 score, let's try to discuss something called as confusion metrics. Okay. So through this confusion metrics, we can calculate all these precision, recall, F1 score, and also accuracy. This confusion matrix is like very confusing, so please pay attention. This is my confusion matrix. It will look something like this. It might be showing related to actual, and here it is showing the result related to predicted value. So in some websites it might be reverse as well, so don't confuse with all those things. We'll be having two classes, right? So this is telling about actual 0th class and actual 1 class. And here, this column is telling about predicted 0th class and predicted 1 class. So like this, my confusion matrix will be there. And all the values that are present over here. That means actual output is 0. And also the predicted output is also 0. In such case, what we call it as? We call it as true negative. Okay. So whenever the actual output is 0 and also the predicted output is 0, that we call it as true negative. And similarly, let's say if the actual output is 1 and also the predicted output is 1, then we call those points as true positives. So these are called as true positives. And similarly, let's try to see what these two are. That means for this, the actual output is 0 and the predicted output is 1. So such points are called as false positives. So this point will be called as false positive. And whenever actual output is 1 and the predicted output is 0, that we call it as false negative. So these are the three different points. So basically some might not get this one. That's why I'm writing separately so that you'll understand it clearly. This will be our false negative. So in order to remember easily, whenever these two match, that matching information will be shown by the first one. Okay. And this second one will be signifying about predicted value. So whenever it's 0, it will be negative, and whenever it is 1, it will be positive. Okay. So whenever there is 1, it is representing positive, and whenever there is 0, it is representing negative. And if these two are equal, then that is represented with true in the first character. Okay. And if they are unequal, it is represented with false. Like that, we can simply identify these true negatives, true positives, and false negative. Now, with the help of this particular confusion matrix, can you guys tell me what will be my accuracy formula? What we'll be having in the denominator? In the denominator, we'll be having the total number of data points. And what are my data points over here? That those are true negatives, false positives, false negatives, and true positives. All of these will be my data points, right? Some are predicted correctly and some are not predicted correctly, but all of them will be my data points. And among this, how many are correctly predicted? So correctly predicted were shown with this true negatives and true positives, right? So in the numerator, we'll be only having true positive and true negative. So like this, the accuracy will get calculated. So if you are taking this particular example, that is 800 0 class points and 100 2 class points, and if the model is blindly predicting everything to be 0, in that case, how will my confusion matrix will be looking like? It will look something like this. So basically, let's say this is actual and this is predicted, and this is 0 and 1, and this is 0 and 1. For how many actual zeros it is predicting it as 0? For all the 800 points, it is predicting them to be 0, right? So here we'll be having 800. And for how many ones it is exactly predicting as 1? As the model is predicting everything to be 0, so for actual outputs 1 also, it is predicting it as 0. Okay. And as it is predicting everything to be 0, for actual output 1, there are 200 misclassified points. Okay. So those will be over here. And these are called as false negatives. And what about this one? This is false positive. That means the model predicted it as positive, but actually it is 0. There are no such points, right? Because the model is predicting everything to be 0 only. So that's why this will also be 0. Like this, my confusion matrix will be looking like for this specific binary classification task. And this is my accuracy formula with respect to the confusion matrix that we are having. And similarly, as I discussed, there is precision, recall, and F1 score. So let's see what is precision. Precision means that out of all predicted positives, how many are correctly predicted. So this will be my definition of precision you can think of. In the denominator, what I'll be having? I'll be having all predicted positives. And in numerator, out of all of these predicted positives, how many are correctly predicted? That information will be having. So this is about precision. And now let's see what is recall. Recall is like out of all actual positives, how many are correctly predicted. So this will be my recall definition. And if we write it in this format, in the denominator, we'll be having all the actual positives. And in numerator, out of all of these actual positives, how many are correctly predicted. This is about precision and recall. Now, according to these definitions, can you guys write down the formulas, like how I wrote the formula for accuracy? In the similar manner, by seeing this confusion matrix and this particular table, can you guys write down what will be my precision formula and what will be my recall formula according to these definitions? Okay. So please write down these formulas in the comment section. And in the next video, we'll be seeing what are these corresponding formulas. And if you are liking these videos, so please do like, share, and subscribe. Okay. Thank you, everyone. Bye bye.